We're going to talk about a new design pattern, composite. Composite is one of the most important design patterns, especially when we need to use recursion relationship. In this motivation, we need to consider building a graphic designer application like Photoshop or any similar application. This kind of application, they have some primary elements or components and build complex component out of this primary component. For example, they know how to build or to draw a line as one of the primary elements. The application know how to draw. And also they have some alphabets and they know how to form a text or a string out of this set of alphabets. And circle as well. And out of the line, they have more complex elements, something like triangle. If the application able to draw a line, they should be able to draw a rectangle out of the lines. So this is the idea that built for most of this type of application, graphic editor, for example. And if the application be able to draw a line, circle, triangle, and adding or embedding some text, this editors should be able to draw a picture, because the picture is out of this type of element. If you start to implement this the way that everyone is using, this is what we think to do. In simple implementation, we're going to have a class for a line, a class to know how to draw a circle, a class to draw a triangle, or showing any text as integrated elements, and a class to draw a picture. This is the normal thing, right? You build one object for each of these primary elements. But it's going to be a complex. It's not easy to implement if each of these parts or each of this object has its own interface. The simple implementation to have different objects for each of these. Object to draw a line, object to draw a triangle, object to draw a picture. To make things easy to grow and to be scalable, we need to make sure that these objects has the same interface. The way we draw a rectangle should be the way we draw a picture. If we be able to do so, it's easy to build something like Photoshop, because you eliminate a lot of internal process if all of them sharing the same interface to draw elements, whether it is a simple element or a complex element. So composite design pattern help us to have that approach. Simple object for each element, all of them sharing the same interface. And if the application know how to draw a line, should be easy to draw a rectangle. And same level of complexity to draw a picture. Because again, the picture is no more than a rectangle, sets of lines that has other combination of primary elements the application know how to draw. If all of them sharing the same interface. Composite design pattern describe how to use recursive composition so that our application, we call it here, our clients don't have to make this distinction between composite elements or primary elements, or it is recursive or non-recursive. Let us start to build composite design pattern out of this example. You can see it in the screen. We have a class to draw a line, a class line. We have a method draw, class circle, triangle, text, and we have a class picture. Each one of these, look at that, have their own method draw, exactly the same method. But we know that the way we draw a line different than the way we draw a picture, different than the way we draw a circle. But still, we need to maintain the same interface. How can we do that? Combine all of them in one abstract class. In this example, I'm calling it graphic, and represent here that common interface so that each of these subclass need to implement. So I'm going to build that inheritance. And if you look at that here, we may have unlimited number of primary elements. And we have one container act as a picture. That container or this picture may have any combination of these primary elements. All of them implement one method called draw. And at the same time, this abstract should give the feature that we can add elements or remove elements. To what? To the container, the picture. Guys, I need your attention here. This is very important to understand that approach. Then it's later on easy to implement it in similar applications. And we also should have a method that we can retrieve any one randomly, not through sequential order. But not only like this. There is no recursion here. What about this container has another container? So this rectangle that represents the picture has another inner rectangle act as part of the picture. So to do this and still maintain the same interface, we add this very important relationship. Look at this. This is the first time we implement one-to-many from the subclass to the superclass. And this is the first time we look at this relation in our program ever. The subclass picture maintain one-to-many relationship to its superclass. And this is the powerful of this design pattern, the composite. One container may have any number of other containers or other primary element or any combination of them without limit, unlimited level of decompositions. And each level of decomposition can be a container or element or combination between containers and elements. Just because adding this association line or whole part relationship, the aggregation. And look at that here. We have here the collection name is called graphics to be defined inside the picture of type graphic. And this is abstract that can be implemented by any number of subclasses, including the picture itself. That means it includes itself. So here in the draw picture is different than draw line or circle. Draw picture need to combine multiple of these elements. So what we do, look at this collection, scan all of them, and then call their own method. For example, if each element is called g.draw. So the picture consists of number of primary elements. We call the draw of these elements inside the draw of the picture. And to add some elements in the picture, because not necessarily all the time to call all of them. We need to call primary elements. So we have here the method add and remove. And add and remove simply add to the collection or remove from the collection. or we may have the method that give us direct access to a specific element in the array. And notice that this picture may contain itself. One picture can has link to itself as well. We may have picture inside pictures. And that interface did the main requirement for design patterns. All of this has one interface called draw. Whether it is a container or elements, primary elements, or any combination of them. So before we start look at the Java example, just again, we need to state the intent for the design patterns. It composes objects into three structures to represent whole part hierarchies. Any relationship like this, whole part hierarchies, one root, the root has some branches, the branches have other branches, until we reach to a branch that has leaf. Any such hierarchy, this is your solution. Composite design pattern is your solution. Do we really need to implement such scenario? Do we need to implement something like this hierarchy? We have the roots. The root has some leaves, so it has some branches. Each branch may have other branch or leaf. Do you need to do so? Okay, so let us consider that example. Make things more clear. Consider a computer file system. We have a folder. Each folder may have number of files and or another folders. And a client needs to display a list of file names and folder names in a uniform way. Are you familiar with the command ls or command dir? The console, ls, what does ls do? Yes.
List all the files in your current directory.
Perfect. List all the existing files or directory and their own internal files if you add /a, right? Or this is Linux-based operating system. For Windows, we use the command dir. How the operating system maintains such interface, we display list of files or list of folders using the same command. We just say ls. ls display list of files or list of folders or a combination among them. Let us see how can we implement this using Java code. So blindly, I implement the composite design patterns. The primary elements, here it's only one, which is file. And the container is the folder. Both of them implement one common interface. I call it here file system to offer implementation for ls. And also we need to add the method to add these elements and have the random access to this element as well. And don't forget that this is the most important part. The aggregation relationship, whole part relationship, and I give it here the role name. So that children is part of the folder class of file system. And the client here is the console, the CLI. You know what they mean by CLI, right? This is the client here. And then when you write ls, depending on how many files do we have, how many folders do we have, how many files inside the folders, all of them should be displayed. But internally, this is your structure. This is the class is going to implement the relationship on the class. No more than that. Okay, so let's look at the code. We have the interface file system offer three different methods, like we have it here. And then we have file to implement this interface. The file implement file system and has one internal attribute to hold the name of the file. We call it here m_name. And then the constructor receive just one parameter to assign that name. And ls, simple way is to display the name of the file. And then we don't have implementation for add or get child because this is not a container. It's just a leaf. So we have here to return null and empty body because this is interface we have to implement. That's simple. Before I move to the next slide, look at the code class and let me know if you have any question. It's very few line of statements, few line of codes. If anything unclear, before I move on, please let me know. Make sense for everyone? Okay. For the folder parts or the container, like the picture, the other example, again, implement file system and maintain the attribute to hold the name of the folder and maintain here data structure to hold all its elements or files. So here we have, look at this aggregation relationship, we call it children of type file system. So children of type file system, it's just an array list. And the constructor for the folder, take any string, assign it to the file name. And then the implementation for the other two methods, add, accept any object of type file system. Look at that. Any object of type file system that can be a folder or a file. We don't know. And add it to the collection. And for get child has integer as an index of this collection and return the specific object in that location in the collection based on the value of r. Okay, what about ls? ls in the previous class for the file, it simply display the file name. But it's different when it comes to the folder. When we need to display the folder, we need to display the folder name and the name of all files under that folder. So what we do, after displaying the folder name, we scan all this collection, we call it children, and for every child, we call its ls method. That child can be a file or another folder. And this is why we say we need to have one single interface, ls or draw. Whether it is a file or a folder, we need to use the same method name. Here, internally, we implement polymorphism again. Polymorphism is the engine that we can implement this. ls here is the same method name, but that can refer to a method for a file or a method for a folder. We don't know. The running time will determine that. And this is the feature for the polymorphism. So the ls for the folder, display folder name, and then display the name of all its contents that can be files or other folders. And the other folder may have other files. Unlimited level of recursion. Okay, so again, before we move to other slides, look at that simple code and let me know if anything unclear for you. Any question? Look at that here. Do we have a recursion here? We call the method ls. And this method is also has the name ls. It calls itself, right? Or it's not. Not all the time it calls itself. It calls itself only if the child that have it here in the array is of type folder. Because it is a combination between files and folders. If it is file, it calls the ls of the file. If it is folder, it calls itself. Because this ls is defined in the folder class. Perfect. So let us move on and look at this implementation. We have the main program. We define 3 folders. The first one is called 1, and I give it the name dir111. Second folder, dir222. Third folder, dir333. And then I created here files, A, B, C, D, E, different files, and all of them I gave their name. And now I'm going to add the file A inside the folder 1 by calling the method add. That means we register the file A inside the collection, which is the folder named 1. We add also file B inside 1. We add folder 2 inside folder 1. And then we add file C inside folder 2. And then file D inside folder 2. And the third folder inside the folder 2. And the folder 2 inside the folder 1. So we can do such things unlimited, very dynamic, during the running time, without the need to change anything on your structure. The structure is built only once, and the program is scaled as much as you can without the need to change anything in the structure. And then if we call the method ls to the folder 1, this is the expected output. Just one command ls for the folder 1. The folder 1 name is 111. We're going to display the folder name and the file name inside folder 1, which is A and B. And then we have another folder, folder 2. And then folder 2 has C and D and another folder. The last folder has the file E. So all of this will be displayed directly by just one command, because we just implemented Composite design pattern. Look at this code class and let me know about your understanding of what we did. Did you catch the powerful of this line here? Goes back to its abstract class, not to itself. If it's just to itself, again, it is recursion, but recursion folder inside folder inside folder. But when we have it to the abstract level, it's not just folder inside folder. It's folder inside. Folder may have other folders and other files as well. So the recursion into the upper level, and the upper level may have any inner representation. Any hierarchy relationship can be implemented by this design pattern. And now there is no doubt how to do it. It is already recorded, use Composite design pattern. Any implementation that require a scenario like any hierarchy relationship between the classes or the requirements, that is your solution. And this is why we're learning design patterns. Okay, so that is the structure. I don't think we mentioned that. The way we do it, we have a component as an abstract. That abstract implemented in sub-children, a composite that link to the abstract, and abstract may have any number of leaves. And that should provide, the abstract should provide one common interface operation that implemented differently by the children, but that should be the same name that exposed to the client. And the leaf should implement the actual operation, because the leaf, they know how to operate itself. For the composite, they need to rely on its children by that link. So this operation rely on that children collection to call the method operation here. and this is here that where we achieve the recursion. And the composite here should provide also a method like add or remove to the collection, and also give the opportunity to retrieve any random element on that collection. And the client should call one interface to achieve the task by calling the operation methods. Questions? Okay, I think we already covered this slide, when we recommend to use it. Now I just repeat it for you. You want to develop a system in which a component may be either individual object or a collection of objects, which is a hierarchical relationship. You want to present a recursive composition of objects, or you want a client to be able to ignore the difference between composition or a collection of individual objects. And the client needs to treat all of them with one uniform interface. Okay, I think that is end our discussion for this design pattern. And let us open the floor for your questions if you have anything related to the composite design pattern.